So I'm Antonio, and I want to present you a way of using serverless for continuous integration for some simple workflows, not for the complex ones. So I use this on the team I'm working with, and we are like 8, and we do mostly front-end development, but we use really heavily CSS regression tests, and they take a lot of time for making the diffing of the images. So it's pretty heavy. We had Jenkins like everyone else. The thing is with Jenkins is it has plugins, and you have to update them. It can do everything. It can do way too much. And with the time, people loses track of the configurations. And even though if you use templates, it gets complicated. This was at the beginning of our regression test. They started by 15 minutes. Then we keep developing the platform, got to 30 minutes, because you start creating more components, more pages, and it gets complicated. Then we introduce in our platform right to left. That means double the time. So now we have every component twice, from the left and from the right. So there was a time for a change. I started experimenting, not with chemicals, but I started experimenting with things. And I found something in Amazon which is called code build and code pipeline. I don't know if you know it. And what I did was changing our stuff to 2 lambdas, and the lambdas are like 300 line of code without the tests. And the build time went to like 8 minutes. This is how it looked like. So if you see the user creates a pull request, then the pull request sends a request to a API gateway. The API gateway then starts a Lambda. And then this Lambda starts a code build. Then code build tells CloudWatch what's happening. And CloudWatch tells another Lambda what to tell to GitHub. So this way you get the whole CI integration with the GitHub API. Actually, I'm really good on time. This was pretty much it. And if you have any more questions or you'd like to know more about how to use serverless for continuous integration and getting 30 minutes per build save 30 minutes per build, come to me in the breaks. Thank you.
Yeah, so I'm Aaron, and I'm here to talk to you about stupid and possibly illegal things that you can do with SMS, and you really probably shouldn't. So first things is I have a demo. It's actually like working live now. I have some numbers that you can text some commands to and see how this stuff works. I have set up a Spanish number for it as well. I haven't tested it because it's a lightning talk. I'm just going to test for those. But you can give it a try as we go along. And the way it's going to work, well, first of all, some caveats. SMS is weird, and it works differently in different countries. Sometimes that's just because of how the telcos implement it, and sometimes because, like, I wasn't kidding, like, some of this stuff actually is illegal in certain countries. So I'm not a lawyer. Don't take any of my advice on what you can and cannot do. Like, it may get you in serious trouble. You may lose some friends. You may lose customers. You may put them in prison. But it's a lot of fun, so we're going to give it a go anyway. OK, so there's the numbers. The way it's going to work is I'm going to put a command on the screen. Like, here's our first command. Hello. Really simple. And it's going to respond with something. So essentially, I've got a little service running in Heroku that's just going to take the command that it receives, and it's going to send back something using the SMS gateways. So these commands are always just one word and like sometimes no spaces and stuff like that. So that's a very, very simple one. If people try it now, text either of those numbers at the top, you're going to get this really simple reply. Boring. So we've got alpha. Now, alpha is not like some toxic masculinity type thing. It stands for alpha sender. So whenever you're sending SMS, the from field is actually an alphanumeric field. So normally it's going to be the telephone number if the message is coming from. It doesn't need to be. It can be a business. So here it's got like Nexmo, which is the company I work for, as like the sender. But I don't need to use my company's name. I can use any company's name. So if you text pizza, you're going to get a message reply from Domino's. So this is like my local Domino's. They send me texts all the time. They use Alpha Sender as well, so like it all appears to come from Domino's. The top 2 are actually texts from them. The bottom one isn't. That's one I've sent myself. So let's get some free pizza. But it still appears to come from them. Okay, so that's not really that interesting. But what about if you use a different company, like, say, your credit card company? So the top message there is an actual credit, or a message from my credit card company. The second message isn't. That's one I've sent myself. They look very much the same. They will appear as they come from your actual credit card company, but the telephone numbers are different. And in fact, you don't even do it for companies. If you know somebody's telephone number, like this is my colleague Mark, and I know his telephone number because he's an idiot and give it to me, I can then start to make it look as if messages come from that person. So the first messages are from him. The last message inviting everybody at a conference to come stay at his house, weirdly isn't. Okay, so voicemail. So this is where we get some things you can do with like binary SMS messages. If you have a phone that still has the voicemail where you've got to phone up and listen to your voicemails, not visual voicemail, which is done like over the web, but actual one where you've got to call a number and listen to your voicemails. If you text voicemail, what you'll receive back is a special SMS that actually is going to tell your phone that you've got 153 new voicemails. Like, you'll get the little indicator and stuff like that as well, and that won't go away. Even if you like phone your voicemail to go, like I would listen to my voicemails, because you don't actually have any new ones, it's never going to send that thing to reset it. So if anybody actually has ran that, I know we're going through very quickly, you can also text, well, you can come speak to me next month and sign up, and I'll tell you how to get rid of it, or you can just text no voicemail. Okay, so pop-up, another interesting one. Pop-up is what's called a class 0 message. These messages, they are displayed immediately, no matter what you're doing on your phone. They're not stored on the device, and they also have to respond to the sender to tell them that you've received it. So they look like this. They're incredibly annoying. They take over the entirety of the screen. And they're also used by governments quite a lot to track where you are because your device has to respond to say that they've received it. Scary kind of stuff. But to get really scary is we've got these things called, so the last command, and I really actually suggest you try this one, is called orders. And orders uses what's called concatenated SMS. So concatenated SMS is like if you've got a message that's longer than like your usual 140 characters, it can, like you can send multiple messages, it'll wait till it's got them all, and it'll piece them back together for you. So this one, whenever it replies, is going to have this hexadecimal string, which is called a user data header. Now, we're not going to really worry too much with the first part of it. It's just like some meta information about like the length of the header, etc. This bit's interesting because that's your ID for this concatenated SMS. That one is how many parts there is to the entirety of the message. So this actually only has one part, so there's nothing really to concatenate together. And the final bit is the sequence number, so where in the sequence this SMS is. So this one here, we've sent in a concatenated SMS that only has one part, and this is that part. So it's just basically a regular message. But the fun thing is what if we send another message that also has the same ID, and it's the same part of this, and the same sequence of the same number of parts? So we can text change, and what will happen is this. So here we can see I've texted orders. It's gone off to Heroku, and it's going through the SMS gateway, and I get this message back, which is going to say, like, I don't care what the CTO said. Make that change in production. If they have a problem, tell them I told you to do it. Okay, so kind of weird message, but then if we get our next one, where we go order, or we go text change, and this is going to trigger another message, and I know I'm over my time by 20 seconds.
Out of time.
And what that message is going to say is there. It actually replaces the message on the device in line.
Hello, I'm Hugo, and I'm a tech lead at Unbabel. When I was a newbie developer, I was really focused on optimizing our requests everywhere. I tried a lot of strategies. It took me some time to understand that it was my shitty code's fault. Now at Unbabel, I learned my lesson, and we are also looking for ways to optimize our services. We decided to test different message serialization protocols. So we chose ProtoWef and MessagePack. Both are very versatile. They can be used with different code stacks. We tested with the Flask web framework. It's what we also used in our internal services. And Locust to run load testing against Flask. So we decided to compare JSON, ProtoWef, and MessagePack. We sent thousands of requests against the Flask service. We used Locust for that. We used 3 different message sizes, and we compared the payload sizes, serialization time, and response times. So as you can see, so in our first experiment, you can see already the impact that using ProtoWef or MessagePack has on reducing the size of the payload. But on such a small payload, such as 74 bytes, there's no such impact that you can use the effort to implement that. So on a medium-sized message, we can already see the benefits of using protobuf for message pack. You can see the number of, an increase of number of requests that you can accept. But the interesting is when you have a large message size with over 100 bytes, the way that Python serializer works, the JSON serializer, sorry, you can see that the increase of the time median response and average response. And it's also beautiful how message pack takes, I don't know, 1/5 or 1/8 of the time compared to JSON. So conclusion from this is message pack is really better compared to JSON when you get to certain sizes. The serialization time and deserialization times are much faster. Protobuf is also good, probably better than message pack if you also compare the time of validating a schema. But it really depends on your use case. So yeah, thank you. Oh,
Wow. So, long ago, when I lived in the Netherlands, I started coding. I used Dreamweaver. I'm ashamed of that today, a little bit. And then came the beautiful world of Sublime and other cool networks and cool IDEs that you can use to write code and to do your things. And then one day, a colleague spoke to me and said, "You should try Emacs." I didn't do that. I tried Vim, which is much better. Wow. This is nice. This is nice. Like, how many people are using Vim here? Just raise your hands. How many Emacs users do we have here? Which is also my colleague. So I'll show you a few cool things. I started to use the terminal, and then I went completely bananas. So I'm just going to give you some examples. Most of the things that I do today are kind of inspired by this guy. I'll make sure this is a little bit bigger here. Which is a super nice quote, by the way. So everything that takes more than 90 seconds should probably be automated. I would go for like 50 microseconds. So let's just try some things here. I'm just going to go through a normal workday, so I'm going to check this out. So I'll clear here, and then...
Bigger. Can you make it bigger?
Bigger. Oh, I can make it bigger. We'll lose all the funny things in the bottom, I guess. Is this... Oh, shit. Give me a second to fix this. This is all in the time, right? Swedish keyboards are not fun, I tell you.
Let's encourage him.
Oh, yes, this works. Nice. And now you can see the entire screen as well. First one to fix this during the entire conference. I'm a little bit proud. So let's go into this fun project that I work on a daily basis in my office, and let's. Now I need to cheat. I need to go to the cheat sheet here. Yeah, let's bring some stuff on here. So let's do brings. If you want to try the things I'm using here, I'll put up a repo you can pull. This is part of the Z-shell lol scripts. They're amazing. Let's just go to clear. Whoops, and then GCB. Some fun. And then let's see. Let's cheat here. Give me something. Then let's NeoVim. NeoVim is better than Vim, by the way, just so you know. Let's go to something here. And let's put some cool text in here. That's probably cool. Now, while you're coding, while you're doing important stuff, music is super important. So let's play some music. While we're at it, this is much better.
Wow.
So I've made this cool file here. Let's quit this. Let's also stop the music. And then let's commit some stuff. Cool command here, also part of the stuff that doesn't work. So let's just commit this. Do you see? This is Vim again. This is magic. Hello. And then let's git push. Now, this is something you deal with every day. I find that shit. So let's put that out there. While we're at it, I could leave the console to check my continuous integration project because I just pushed this to our production server. So let's do that. And you see that some fun is now successfully running on our CI. This is Circle CI. There are some command line interaction programs here you can use. And then, yeah, lots of cool stuff. Let's see here. I don't have time left. You should be blinking. Yeah, I think that's most of it. Let's end with maps because that's cool. At least the weather is nice. Goodbye.
Okay, hi. So who has had stories like this in the past? Like stories where it was like, okay, we need to fix all the security, or like a tricky conversation with your product person to convince them of addressing like a very urgent issue. It's pretty hard, right? Today, I want to talk real briefly about threat modeling. I've run a couple of workshops with a couple of teams in the past, and it's a really fun and collaborative workshop that leaves you with a bit of a better situation in these situations. The outcome of a threat modeling workshop is to come up with a backlog of stories that are manageable, that are easily prioritizable. And it's useful to bring the whole team on the same page when it comes to talking about security. So it works like this. First, you decompose the application. That's really a fancy word for saying drawing a diagram. So you really wanna bring everybody together and create a diagram collaboratively. It doesn't really matter what you look at. You can look at maybe the data flow. Maybe you want to look at your network infrastructure. Maybe you want to look at where are the boundaries within your system, where's the trust boundaries. It doesn't really matter. It's the value is in talking together about it. Then as the next step, instead of jumping right into a concrete vulnerability, try to reverse the process. Try to think about who is a potential attacker of your system. Try to come up with a realistic persona and put yourself in the shoes of a potential attacker. Once you've done that, you can go on to identifying threats, and attack trees are a really powerful mechanism to do that. So pick an attacker and a goal, and continuously ask yourself, how will I be able to achieve this goal? Do that a couple of iterations, and then it will leave you with a tree like this, where at the bottom level you hopefully have a concrete attack, and the path throughout the tree hopefully tells a story of how somebody would actually go and do a successful attack on your system. Once you've done that, you create a prioritized list of the vulnerabilities you've discovered. There are some models that help you do this. You basically want to make it as concrete as possible and think about the potential impact if somebody exploits this vulnerability. For example, in terms of dollars. And you want to think about the likelihood that somebody actually goes and attacks your system in this way. So it's a basic approach to risk. You have the combined risk is the impact and the likelihood. After you did that, you want to think about a potential mitigation. And while we, as techies, we are often tempted to just fix all the things, I just want to leave the thought with you that there are more ways to address a potential vulnerability. So you might want to, for example, accept a really low risk, or you might want to talk, you want to inform other people about the risk. But of course, yeah, mitigation is most likely done by actually fixing the vulnerability. So this is one way to run a threat modeling workshop, by first decomposition, then coming up with attack scenarios, then identifying threats using attack trees, then prioritizing them, and lastly deciding on a mitigation strategy. Yeah, I'm Klaus. I'm a developer here at ThoughtWorks in Barcelona. We have a relatively new office with a couple of people motivated about building secure software. If you want to find out more about this, I didn't come up with any of this. You can Google for these things, or better use DuckDuckGo. On OWASP, you have a comprehensive list of resources for if you want to do a threat modeling workshop. My colleagues have written on the ThoughtWorks blog about this, and you might also want to check out Dread and Stride, which are models that help you learn more about threat modeling. Thanks a lot.
All of you are basically magicians. You create stuff from nothing every single day. And I think people like you over the last decade, the stuff they created impacted society virtually in every single way possible. That's a huge power we have, every single one of you. And as you all know, with great power comes great responsibility. And that's what I want to talk to you about the responsibility we as individuals have while we write code. That's obviously very subjective, and I'm by no means an expert on the topic at all. But I want to talk a little about it, reflect a little with you about it, and just spend the next 5 minutes talking a bit about the big challenges, the smaller challenges, and what we can do as individuals. I think recently we had some big scandals, the diesel scandal with car manufacturers such as Volkswagen. And I think the software engineers that put the code in there that said, if you're in a testing environment, behave differently, he probably was very aware that what he's doing is not so cool. Similar with Cambridge Analytica, the people working there, they probably were aware what they're doing isn't the best thing to do. But I don't think it's always that easy. Often we build tools that can be used for something good or something bad. Think image recognition. You build image recognition. It's not inherently bad. You can use it for nice things. You might want to tag automatically pictures with friends in there. Or you might use it in drones to kill people, target people. So, it's not always that straightforward. And you don't necessarily always have a choice, especially on the day-to-day stuff. The business needs go against security. You don't have the time. There are tight deadlines. It's not necessarily a decision to make. Your product manager comes in, your boss comes in and tells you to do it, and what are you going to do? You have to feed your family. You can't risk your career every day for those kind of things. But I think it's our responsibility that we reflect on that and we talk about that. And the small things like that, we can speak up, the security things. If you go back to Cambridge Analytica, at Facebook, I think it was pretty clear to some of the engineers there at the time, if we leave this Graph API open like that, that is a risk, and I might not be willing to take that, or I might be. Different people have, different values about that. Or misleading wording. If I look at the gaming industry, especially mobile gaming, a lot of those things they do, I personally wouldn't feel comfortable with, and that's, again, different for everybody. But misleading wording using psychological tricks to, get people to do something that is not necessarily in their best interest. And I find it interesting that often, especially in pop culture, the reference is made, if I could travel back in time and change one small thing, what would it be? What could I do to change something important? But often we don't step back and say, what can I change today to make this big impact in the future? Which is essentially the same thing. So let's think about that as well. And I think often it's not one big decision that we make. it's not on one day we have to make the decision, do I do something good or something bad? It's all the small decisions every single day that put you onto a path. And you have to decide every single day what that path looks like for you and what's important to you. And you don't always can do that. Again, there are tight deadlines. You can't take so much time about every single small thing to think about it. But in the big picture, you should, I think. And not always there's a clear good and bad either, right? Sometimes, yeah, you know that's probably wrong, but often you don't. How could you? What are you doing? And what can we do? And I honestly don't know. If any of you has a good idea, please tell me. But I think a first good step is just awareness. Be aware of what you're doing. Be aware of what's important to you. For example, this conference organizers decided they have a code of conduct, which is something that's important to them, that's something that they want to promote. And I think something similar we need as individuals. Have your own personal core values and think about them and write them down. And I think that's something all of us can do as a starting point. Think about your personal core values, write them down, 1 or 2, do that now. Thank you.
Does anyone else think that the stage looks a bit like a smiley face? Eye, mouth. Hi, I'm Rufus. I also work at ThoughtWorks, like Klaus, although I'm based in the New York office. I co-founded and co-organized the ThoughtWorks front-end community. I have no slides prepared, and I did this on a whim. So I'm just going to talk at you for 5 minutes, I guess 4.5 minutes now, about things that I think are interesting. And even if you don't think they're interesting, at least it'll be brief. So I'm a functional programming enthusiast, definitely not an expert, but I draw a lot of inspiration, especially from the Clojure community. So yesterday, Ray Krantz gave us a brief introduction to the Clojure mindset, and I want to just expand on that a little bit. So this talk is called Heraclitus Slays Zalgo. If you're not familiar with the term Zalgo, we'll get there in a second. But it was inspired by a talk that Rich Hickey, the author of Clojure, gave. He gives these really long-winded, almost philosophical talks. Tom Enden mentioned a different one earlier, which is called Hammock-Driven Development. The one that inspired me is about concurrency, so of course it's called Are We There Yet? And for me, that talk was an invitation to examine one of the most basic assumptions that we have, which is the concept of identity. A lot of the time in programming, we make a thing and then we change it, but we expect the thing to still somehow be the same thing. And I think it's really interesting to think about whether that's really true. In what way are you meaningfully the same as when you were a child? Everything about you is different. The way you talk, the way you think, the way you look, your abilities, your values. Are you really the same? Does it make sense to think of you then and now as connected by an identity? So Rich Hickey has this quote that he paraphrased from Heraclitus, a Greek philosopher. And the quote is, "A person can never step into the same river twice because they are no longer the same person and it is no longer the same river." The original quote is a bit more poetic. It says something along the lines of, "Upon those who step into the same river, different and again different waters flow." But what does this mean? To me, what this means is that the idea of having something like a river that is unchanging is nonsensical. And really there's only a stream of values over time. So at one point the river looks like this, at another point the river looks like this. So the observable nature of the river changes and therefore it cannot be the same. It doesn't make sense. But let's see how that applies to our work, our everyday work as software developers. Here's an example from the Node community. There was a quite well-known article written about 4 years ago from Isaac Schluter, who is the CEO and founder of NPM. It was called Designing APIs for Asynchronicity. I don't know if anybody has read it. It made the rounds. And basically, he makes the point that there should be no such thing as a potentially asynchronous API. So if you pass a callback to an API, it should either always call it synchronously or always call it asynchronously. If your callback is invoked unpredictably, you invoke Zalgo. And what that means is chaos and despair and potentially devastating mutation state bugs. Isaac Schluter also said that it doesn't matter if you use callbacks, promises, generators, or whatever other async handling mechanism you want, this problem always exists. There was another article that only got like 80 claps on Medium, so I want to elevate a little bit, that I think shows that this is not actually true. This is an article by a tech lead at PayPal. His name is Daniel Brain, which is a really cool name. And they basically went ahead and built a promise implementation that can be either synchronous or asynchronous. And they've been using it in production for a while, I think more than a few years now, and they've had no Zalgo-related state bugs. So why is this? He makes the point that the real issue isn't with callbacks or promises, or even with inconsistent sync or async. It's with modifying state that's outside of the scope of the callback or the promise. So that's what you might call an identity-oriented approach to the world. So like something that's maybe more traditionally object-oriented. Because you think of the state as an identity that remains referenceable even while it changes, while it mutates outside of the scope of the callback. So promises, this pattern is usually easy to avoid because you can use then to lift the operation that depend on the data into the promise context rather than having to modify the outside world. So that's a much more Heraclitean approach. It solves the Zalgo state issue because there can never be an inconsistent or unexpected state, and any operations that require the state will resolve in the context of that state. So, in conclusion, let go of an identity-oriented view of the world, and Zalgo remains caged. That's why Heraclitus slays Zalgo. Thank you.